So another slide to compare permanent magnet motors from induction motors. In terms of development, the permanent magnet motor was introduced for the ESPs in the early 2000s, while the induction motor is a traditional motor type. While manufacturers will tend to tell you that the permanent magnet motor will be more reliable than the induction motor, in some cases, you will be using prototype of permanent magnet motor. They won't have as much experience with this type of motor than with induction motor. So while they tend to say that they will be more reliable, from my experience, I find that induction motor tends to be more reliable than permanent magnet motor. That being said, this applies for the very specific applications that we have on the fields on which I've been working recently, where we have very high rates pumps, so very powerful permanent magnet motors used. So you might have a different experience if you are using smaller systems which have been more widely used, and maybe in that case the permanent magnet motor might be more reliable than the induction motor. But just don't take for granted whatever you read in commercial brochures. So in terms of rotor construction, the permanent magnet motor includes permanent magnets, which are hard sintered rare earth metal pieces, while the induction motor has a squirrel cage with short-circuited copper bars. For the rotor magnetic fields, it is created by the permanent magnets. Therefore, it is constant. The drawback of that is that you will have a demagnetization over time due to the finite life of the permanent magnets. In the case of an induction motor, the rotor magnetic field is going to be generated by the currents induced in the copper bars. And so this rotor magnetic field is where the main difference between the permanent magnet motor and the induction motor is. And as this magnetic field in the rotor does not require magnetization currents, this is where the power is saved, as you have no energy which is being used to generate this magnetic field. Next parameter of comparison, the stator magnetic field. For the stator magnetic field, it is the same for both types of motor. It is created in the stator when alternating currents is applied to non-rotating stator windings. And so this magnetic field generates the rotor torque for both the PMM and the induction motor. Now, in terms of slip, if you remember, for the induction motor, the slip is necessary so that you can have torque created. So your induction motor will be operated with a 3 to 6% slip. Basically, your rotor is going to turn 3 to 6% slower than the speed at which the stator magnetic field turns. So this is required so that you can create the magnetic field in your rotor so that it can actually turn. In the case of a permanent magnet motor, as the magnetic field in the rotor is permanently present, the rotor will turn at the same speed than the stator magnetic field's rotation speeds. And therefore, PMM motor will have no slip. So therefore, permanent magnet motor are called synchronous motors, while induction motor, because they have this slip, are called asynchronous motors. Now, in terms of VSDs, so variable speed drive, with a PMM, a VSD is necessary to operate the system, and you will need to have a special control algorithm in your VSD. So therefore, some VSD can be used on induction motors only, while if you want to use a permanent magnet motor, you will need to make sure that your VSD is compatible with it. And typically, a VSD which can operate a permanent magnet motor will also be able to operate an induction motor, while the opposite might not be true. VSDs that can operate induction motor are not necessarily equipped with the special control algorithm that will allow them to control a permanent magnet motor. Therefore, this creates compatibility issues with legacy VSDs. So if you already have many ESPs installed on your sites and you have many VSDs already available, when you want to replace your pump and switch from induction motor to permanent magnet motor, you might have to replace your VSD or use an upgrade kit on that VSD so that it can operate your permanent permanent magnet motor. On an induction motor, VSD are also optional. Sometimes you can just use a switchboard, so just operate your induction motor at a constant frequency, which is going to be equal to the electrical frequency of your network. So typically 50 Hz or 60 Hz, depending on which area in the world you are. Now, that being said, while you can use switchboard with ESPs, nowadays most of ESPs are equipped with VSDs, as this brings additional flexibility and reliability to the ESP system. So your permanent magnet motor basically is going to bring energy savings due to the higher power efficiency, as you do not need to create the magnetic fields in the rotor. They have a better power factor than induction motor, and also because you have no slip. So basically, for a given electrical frequency, your rotor will turn at a higher speed than in an induction motor. Therefore, your pump is going to be operated at a higher speed and will either deliver more heads or more rates, or a combination of both.